For 74,000 years, something invisible was deciding where humans could live and where they would disappear. Deep in sub-Saharan Africa, ancient populations were moving. Not because of mountains, not because of rivers, because of something far smaller, a mosquito. Scientists at the Max Planck Institute of Geoanthropology, working with an international team, recently mapped something extraordinary. They overlaid models of where mosquito populations thrived across ancient Africa, alongside paleoclimate records and archaeological evidence of where early humans actually lived, going back 74,000 years. What they found was unsettling. The maps aligned in reverse. Wherever Plasmodium, falciparum, malaria was likely rampant, human populations were absent or gone. Entire stretches of landscape, warm, wet, resource-rich, were effectively no-go zones, not because humans chose to avoid them, because the ones who stayed didn't survive long enough to pass on their genes. This wasn't just survival. This was selection, playing out across tens of thousands of years on a continental scale. Climate and physical barriers were not the only forces shaping where human populations could live, said Andrea Menica of the University of Cambridge, one of the study's contributors. Malaria fragmented communities. It divided populations that might otherwise have mixed. It created isolated pockets, genetically, culturally, geographically, and those separations compounded over generations. The genetic diversity we see in African populations today, some of it traces back to this. The population structures that distinguish one group from another across the continent. Malaria played a role in drawing those lines. And here's where it gets even stranger. This research focuses on 74,000 years, but the researchers believe the effects began even earlier. The full scope of malaria's influence on human evolution may be larger than any study has yet captured. We tend to think of history as shaped by leaders, wars, migrations, ideas, but a single-celled parasite carried by an insect that weighs less than a raindrop may have quietly determined more about who we are, where we come from, and why our populations are distributed the way they are than almost anything else. So the next time someone talks about human history, about borders, ancestry, identity, maybe the real story began in the hum of wings at dusk, above a warm African lake 74,000 years ago. What else have we been missing?